Hi everyone, so I'm going to talk about the 2014 Calc AB FRQ number 2, and so here it is. So they give you this graph with region R, and f of x is equal to x to the fourth minus 2.3x cubed plus 4, and y equals 4. So that's the graph I tried to draw it as closely as possible to the one on the FRQ, but so there it is. The question asks, what's the volume of the solid generated when region R is rotated about y equals -2? So the -2 here. And so how you first want to set this up is you have to set up your integral. And so first things first, you have to set f of x equal to 4. You have to set the equations equal to each other so that you can find the points of which this region R is going to be enclosed by. So you're going to do f of x is equal to 4. And then you plug that into your graphing calculator, and you're going to get x equals 0 and x equals 2.3. So you know that those are your bounds for your integral. And on the scoring guide of the FRQ, they want to make sure that you get these points. Like, that's part of your credit that you'll get. So you set up your integral from 0 to 2.3. And then you have to think about this next part conceptually. So you have to think of 4. You want to think like 4 to the x-axis, like your graph's to the x-axis. And so from here to here is going to be rotated about the x-axis. So to get this extra region to rotate it around y equals -2, you're going to have to add this space so that you rotate it fully around the y equals -2 line. And so then also next you have to make sure you hollow it out with this f of x part so that you get region R actually rotated around it. So you're going to do the same thing. You're going to like actually add 2 to rotate it, even though it's like -2. So you're going to set it up like this. You do 4 plus 2 squared minus all of f of x plus 2 squared, and then don't forget your dx. And then also the next part is you want to make sure you have a pi in front of your integral. Otherwise it's just going to throw it all off. So you don't forget the pi. So it's going to be like that. And so once you get this, you're going to plug it into your graphing calculator, and you're going to get your volume is equal to 98.868. So that is it right there. So the graders are looking for your integral setup and your bounds. I think one other thing. Oh, yeah, and the answer, obviously. So that is your answer to number 1, and yeah. Okay, so now here's question 2, and I showed the graph again if that helps. And so the question asks, region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So what you're first going to want to do is think of, so it's a cross-section question, and you want to look at your shape, which is an isosceles right triangle. So this is how you're going to set up your integral. So to find like how you're going to set up your cross-section, you have to find the area of your shape. So you know that an area of a triangle is base times height over 2. And in our case, I didn't draw this very well, but in our case, these two sides, since it's an isosceles right triangle, should be equal to each other. So you can just rewrite this as a side squared over 2. And so this S is going to represent like this region R right here when you set up your integral. So to set up your integral for the cross-section, you're going to use this side squared over 2, and you're going to say the volume is equal to 0 to 2.3, because we found that in our bounds in the last problem. And you're going to pull out this 1/2 from so it's 1/2 side squared, or your region r squared. And then your region, to find r, like this area here, it's going to be 4 minus f of x, and then you're left with this section. So you're going to do 1/2 times 4 minus f of x squared, because it's side squared, and then dx. And you don't have to put a pi in front when you're doing cross sections unless it's the shape that you're looking for. So if I was to do semicircles, it would be pi r squared over 2, or pi side squared over 2. And you'd pull out a pi over 2 in front, and then do your r, your region squared. So don't put a pi in front unless that's what it's asking you with your cross sections. And so once you plug this into your calculator, you're going to get your volume is equal to 3.574. And that is your answer. Okay, so now we have part 3 of the 2014 FRQ number 2, and it asks, the vertical line x equals k divides r into 2 regions which have equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So right off the bat, you know that you're solving it with an integral. Not sure how you did otherwise, but it explicitly tells you that, so you have to set it up that way, otherwise you won't get your points. So this is a total conceptual problem, and so the vertical line x equals k is going to be probably somewhere about here, right? And so you know that the areas equal each other, so right off the bat you're going to have 2 integrals that equal each other. And so since this k divides region r in half, you know that your bounds are going to still be from 0 to 2.3, and so you're going to use those and k as your bounds. So for the first integral, for the first area, it's going to be 0 to k of 4 minus f of x dx. And you're not squaring it because it's the area. It's asking for the area, not the volume, so do not square it. And then your next integral, it's going to equal the area from k to 2.3. So that's your second integral, and it's going to be from k to 2.3 of still 4 minus f of x dx. And that is all it's asking for. You have